keep target to finish up the module number 1 in next 2 to 3 lectures. 2 lectures at the most. Okay. Rest I will give you as an assignment problem. Then we will jump to module number 2, module number 3, because till module number 3 or at least 50% of module number 3 will be in your medicine syllabus. So in our case what we are doing? In this case, the case study we have taken of ADXL 150. Which one we are adopting? Which one? Pulse width modulation. ठीक है ना? You are allowed to change this one. This is my standard equation what I want to achieve. Okay. Now in last session, a very interesting question asked that if T is equal to T naught, in case of frequency modulation and allowing to change the F is equal to F naught KF MT, that will be my standard equation. Now to achieve this, I have to assume rest are constant. So to keep it constant, I have to fix E is equal to E naught, that is I can do. A is equal to E naught, that I also can do. What else? 5. 5 is equal to 0 I can take, or for simplicity I can make it 5 naught. Whatever you can take. Simply you can take 5 is equal to 0, no problem. T is equal to T naught. But ultimately you have to keep it. How will you do? I think you have not referred those contents. You have purely celebrated the full vacation. Right? Neither of you are vacation. What you do, that which portion is actually providing the information? There is something we call duty cycle. Now duty cycle, can it be constant or not? What is duty cycle? This by this active duration with respect to whole period, that is not. So can I make A by T? Remember, A is also modified, T is also modified, na? But A naught is a constant. Yes? And A is changing with A naught is also constant. That is change in time. This ratio and this ratio can it be made same or? Like 1 by 5 is equal to 4 by 20. You are allowed to change 1 to 4. You are allowed to change 5 to 20. So is it varying or not? It is varying. Can you make duty cycle constant? That is the technique. How you do adjust keeping one constant, allow the other to. Okay. That's why I say that you have to apply some additional engineering. Okay. Let us forget it. Let us take the base part, because F part will be slightly more difficult. Here you simply allow the changing input. What will happen? So if now this E is changing, okay, na? So if E is changing, so I will get this function is equal to E for which duration? For this active duration. So that is your on period, na? Isn't it? And this part is your off period. This part is also your off period. Is it? Okay. So this changing value should be available for this duration. Satisfy this condition. Otherwise it should be 0. Yeah? Otherwise it should be 0. Okay. So can I explain this function or this model by writing the Fourier series expansion? Fourier series expression? Yes? And for a kth value, if k is some constant, can I write it in this way? Where the coefficient of the function is defined by this. Good. If it is so, then give me the value of Ck. Find it out. Solve this function and find the value of C coefficient. Because now for each value of k, if k is equal to 0, it is a DC signal. If k is equal to 1, that is the first harmonic. K is equal to 2 will give a second harmonic, so and so. So I want to check that what is the contribution of each coefficient to carry my data. How much power is carried by which particular coefficient or which particular harmonic. Getting my point? Complete value, complete information is with all the value of k. Remember, huh? But to have the any value of k, remember what is the minimum amount of bandwidth you require to reproduce a signal at receiver end? What is the thumb rule? 2 times. 2 times of the input minimum. Okay, remember, है ना? Now this is maybe satisfactory for your industry. For your communication system, may not be satisfactory for industry. Remember, because in communication system, what happened? You are dealing with a very limited signals. Okay, you can afford to have a very complex modulation and demodulation systems. Because modulation and demodulation systems are limited, users are infinite. Understand? Are you getting my point? You do not want to add more complexity within this device, but you can add as much as complexity you want at your nearest wireless tower, because that is static. And from that point to this device connection is very limited. Getting my point? That's how your wireless works. Okay? It's not that every demodulation circuit is here. If it will be there, it will be something like the size of half kg, 1 kg device. Some form of demodulation is there, but this device is not prepared to demodulate a data of 36,000 km per deploy. So calculate the value of C. Now what you will do? What is the period here? Simply take minus a by 2 plus a by 2. Because rest is inactive, you don't require to do. ठीक है? Calculate करो, check करो whether you are getting don't write straightforward in your examination. Something like you will get this, right? Or for my representation purpose, I am purposely modifying it. E upon k pi into sine, I am keeping here k pi into a by b. Now this a by t is a duty cycle. Okay? So if it is 50%, I can straightforward write in place of a by t, I can take 1 by 2. If the duty cycle is 25%, I can simply replace it by 1 by 4. Yes? If it is 1 by 3, I can simply replace by 1 by a by 2 is replaced by 1 by 3, 33%, whatever you want. See? Pick up. Just check whether you are getting this. And if you got it, your next job is that calculate the value of C naught for k is equal to 0. What is the value? This equation is correct. Solve it. Because this Ck coefficient is very important. Minus this to minus 0 k over t, no? So duration is minus a by 2 to plus a by 2. So you will get the function of e raised to minus j k omega a by 2 minus of e raised to plus j k omega by 2. Shift कर दो, ठीक है? So is as good as like you are getting how much? E raised to jk is your cos theta plus j sin theta. E raised to minus jk is cos theta minus j sin theta. So your odd component cancel, है ना? Okay. So ultimately you will get E upon in denominator you will get jk omega t into 2j sin within bracket k omega a by 2. ठीक है ना? So this j ultimately is an imaginary term, cancel it. Rest को थोड़ा सा modify करो. E upon k omega t you got. E upon k omega t you got ना? अच्छा. Can I write omega is equal to 2 pi by 2? dt cancel करो और सिंपल हो जाएगा. So you will get e by 2k pi, correct. ठीक. अच्छा 2 इधर तुम्हारा न्यूमरेटर में है. अच्छा ना 2 sin 2 कैंसिल कर दो कौन काम हो रहा है. नाउ इट इज e by k pi into sin k pi a by t. आगे got it? You must have this, you take this xerox, no problem, है ना. ठीक है. So this equation is correct. Okay. Bottom one is also same. Purposely I have rewritten to highlight this portion. Okay. So remember this one is valid. This statement is valid for anything k is not equal to 0. For k is equal to 1 to n, fine. If you have n number of harmonics, n is countable. If n is tending to infinity, then it's a perfect theoretical value. But I have to fix the upper limit. Let's say upper limit is some n, some capital N, numerical. Okay? It can be 10, it can be 100, it can be 50, I do not know. Okay? Now, it will start from k is equal to 0. But can I substitute k is equal to 0 here? Huh? So now give me the values of C0. The first DC value. वो कितना आएगा? To my calculation, it should be E into A by T. Is it or not? You check. This is right or wrong, I do not know. If it is yes, why? If it is no, why? You check also. अच्छा, if k is not equal to 0, anything for k is not equal to 0, sin theta by theta or sin x by x, some 1 or 0, k is not equal to 0, I must say. And for k is equal to 0 then? Yes, all clear? So I'll just write down my final equation. Dynamic. D for Q to B and for K equal to 0, it is E into A by T. Why? 0 tends to 1. So it is e by f or e by 2. ठीक है ना? For k is equal to 0, ना? For k is equal to non-zero, this one will be tending to 0, not 1. Okay? Anyway, what is important for us here, that for C0, I will follow this. For anything non-zero, I will follow this. Okay? Now for our practice purpose, you assume that let's say a by t is equal to 1 by 4. You can take any value, you can take 1 by 2, 1 by 3, up to you. Okay? Rather, I would advise you that solve this part, same part, as a part of your assignment, considering a by t is equal to 1 by 3. That is your assignment problem. Okay? Practice. Now for our practice purpose, we will take 25% duty cycle. Okay? Now if you have taken 25% duty cycle, so I'm now removing the rest of all. Here you are taking let a by t is equal to 1 by 4. Can you draw it? That is changing with k. That is the value of coefficient. Now coefficient can be positive or negative with time. So I do not know. So I am considering the mod value. Okay. So because I took this one is how much? 1 by 4. 25% of duty cycle. So that means this C naught, the DC value will be equal to E by 4. Okay? Now E is the sum volt. So ultimately it is E by 4. Okay? Some magnitude. Now give me a pattern. All of you calculate. This is what if k is equal to 1. What is the magnitude? Tell me. K is equal to 2. K is equal to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At least up to this many numbers. You can go even beyond also, but just calculate it. What is at 1? What is at 1? K is equal to 1, na? Okay? So it is operating at k is equal to 1. Which frequency will get? Fundamental frequency? Yes, na? So that means here you are getting fundamental frequency. K is equal to 2, 2f. Third harmonic, fourth harmonic, and so on. Okay? Calculate. At 0 it is E by 4. At 0 it is E by 4, na? Okay? K is equal to 0. If K is equal to 1, then what is the value? Calculate. It is E by pi sin pi by 4. कितना है? E by root 2 pi. Root 2 pi is how much? Tentatively calculate. Root 2 is 1.1. Pi is 0 point? More than 1 or less than 1? Less than 1, na? So tentatively I am taking this value. Okay? Tentatively I am considering this is my value. And this value is E by root over 2 pi. ठीक है ना? Yes, side by side I have kept on writing. For k is equal to 0, है ना? C1 is equal to E by 4. For k is equal to 1, sorry, C1 is equal to E by root over 2 pi. For k is equal to 2, C2 is equal to second value. Calculate quickly. By 2 pi. Earlier is root over 2 pi, now it is 2 pi. So denominator is increasing. So numerator will, ratio will decrease. So what is it? Tell me the exact value. 6.28. So that will be 0.65 something. Then k is equal to 3. K is equal to 3. K is equal to 1 e by root over 2 pi. K is equal to 2 e by 2 pi. K is equal to 3 e by 3 root over 2 pi. है ना? ठीक है? Definitely around I think 0.4 something or 0.3. देखो कितना ऐसे. If 1 is my reference. E by 4 itself is 0.25. For simplicity I am assuming 0.25 is 1. So then what is it? That's why I said 0.64. Huh? So it is e by root 3 root over 2 pi. Okay. Now at 4f. Next. 0. Very good. So it started from here. Is this not? So this distance is 4f. This distance is 4f. Right? F is equal to 1 by t. F is equal to 1 by t now. So if a by t is equal to 1 by 4, satisfied? So that means that is my first loop. This is called your first loop. Ending at here. Now calculate at 5f. For k is equal to 5. Again some non-zero value. E by 5 root over 2 pi. है ना? For 6 e by 6 pi. Now e by 6 pi is higher value or e by 5 root over 2 pi is higher value? 5 root 2 is higher or 6? 5 root 2. So that means e by 5 root 2 is lower value as compared to 6. That means you are increasing the magnitude. Now calculate 7 root over 2. Again decreasing. 8. 0. So something, just calculate later on. Okay. Something abruptly I am calculating. It is moving like this. Okay. So this is my second loop. How up it will go, that also decides. So remember, this part is magnitude. Vertical is magnitude. This part is bend. Okay. So this is my second loop. Varying from 4f to 8f. 8th component is 8f. Yes. Just tentatively calculate. Do one more calculation. What is the value of 9f? 0? No. Some non-zero value. What is it? E by 9 root over 2 pi. Now e by 9 root over 2 pi is not 0. Some non-zero value. So that means above 0. What is 10? E by 10 pi. Now 9 root over 2 is higher value or 10? 9 into root over 2 is higher value or 10? So e by 9 root over 2 will be higher magnitude or e by 10 will be higher magnitude? E by 10. Then e by 11 root over 2 pi. Again decreasing. E by 12. 0. So probably the next cycle will move like this. Something like this. Not perfectly wrong. Something like this. Yeah. What is the change in amplitude in first loop? E by 4. 25%, right? If it is 25%, then this value is far more value. What is it? E by 6 pi, calculate. E by 4 is higher value or E by 6 pi is higher value? What is the percentage change? Just calculate. For your reference, you will come to know. For a simplicity, you can take E is equal to 1, no problem. Just calculate 1 by 4 is equal to 0.25. Obviously, here you have taken E by, A by T is equal to 1 by 4, na? Even you assume E is equal to 1 for your calculation. So, if E by 4 is equal to 0.25, then what is 1 upon 6 pi? जल्दी बोलो. सेवेंटी इनवर्स इट. सो डिनोमिनेटर ना इनवर्स इट 0.00 है ना. The first magnitude is 0.25. So the second magnitude is highest is 0.00. Okay. Okay. Okay, no problem. So the first magnitude highest value is DC value, it is 0.25. So the next magnitude highest is nearly 100 times less, है ना. And the first AC value is, first harmonic is E by root over 2 pi.